Hello and welcome to Sean White's Solar and Energy Storage Podcast. This podcast is titled the 2018 International Fire Code. That's the IFC for Energy Storage Systems. That's ESS, and that is with Bill Brooks. And we're going to also talk about different topics while we're talking about the IFC, because the IFC brings up other interesting topics. And now let's talk a little bit about this podcast. Although this podcast is based on the 2018 IFC, and it obviously is not 2018, at least where I am, don't worry about it. There's all different places that adopt different versions of the IFC. I would think that most places right now are on the 2018 IFC and not the 2021 IFC, which just hasn't been adopted everywhere. In fact, just a couple of weeks ago, I taught an energy storage system class to a bunch of inspectors that was based on the 2015 IFC because they were in a state that uses the 2015 IFC. Things like that are just common, but you will have to check with your own state to see which version is adopted. And another thing is most of the language between different versions is the same. So understanding one version means you understand the other. So don't be one of those people that overly worries about studying a different version of the code. You have more important things to do. Some of the topics we're going to cover here include large-scale fire testing, also known as UL 9540A, FMEA, container batteries, or shall we say container energy storage systems, lead-acid batteries, NiCad batteries, beautiful lithium-ion batteries, maximum battery sizes, maximum allowable battery quantities, UL 9540, that's the energy storage system listing, UL 1973, EMS, which stands for Energy Management Systems, and BMS, which stands for Battery Management Systems, and probably a few other things. So to learn this stuff in more detail, take some of my energy storage classes at HeatSpring, and you can find links to my classes at heatspring.com/Sean, or you can get that from solarsean.com. So let's get on with this show.
2018 IFC. So this is the basic requirements that are applicable to storage systems providing electric power to buildings or facilities, provide standby, emergency power, or uninterruptible power supply, load shedding, or similar capabilities. And so then there's going to be some items. There's that table that we already talked about, and if it exceeds these numbers, then you have to follow rules. If it doesn't exceed these numbers, there's no rules to follow.
No rules.
Woo. No rules.
Yeah, one of the weird rules that I always thought too was just like for lead acid batteries, they don't have to be listed.
Correct.
So we could just make some right now.
That's true, but I can guarantee you it will cost you more money than it will to go down and buy one.
We'll just get your old used ammo.
That's right. Okay, this is kind of somewhat a silly one, I think. Permits shall be obtained for the installation and operation of storage battery systems. Why is this in the fire code? I don't know. It's an electrical system. It would have to get a permit, but I think that allows maybe the fire service to get involved, and I think that's maybe why they have it in there.
So just more about permits.
Yep. So they want an FMEA, failure modes and effects analysis, or other approved hazard mitigation shall be provided in accordance with under any of the following conditions. When the battery technologies are not specifically shown in the table, which the main ones are, more than one stationary battery is provided in a room or indoor area where there is a potential for adverse interaction between the technologies, whatever that means, but they do have a 3-foot spacing requirement, which essentially says that that's not a problem, or where allowed as a basis for increasing maximum allowable quantities. And so on a large battery room, they're going to want to have some kind of FMEA analysis, and that's not going to be a big deal because that would be a pretty typical thing.
Is that some kind of thing that you would do as a professional engineer? Or?
Not me personally, but there are professional engineers that specialize in those types of analyses and would do that kind of work. Okay, so let's talk about fault conditions. Hazard mitigation analysis. Does this sound familiar? Kind of sounds like PV hazard mitigation. Shall evaluate the consequences with single mode failures. That's an important concept. We're not talking about multiple failures, but this is providing details on the FMEA. Thermal runaway analysis, failure of the energy management system, failure of the ventilation system. And so basically, if you're the engineer, this is what you go to and say, okay, I'm going to provide you a report that covers all these items in my FMEA.
Okay. And so it's pretty much going to be an engineer doing all this stuff.
Correct.
And is this something that you would do, or you would instruct other engineers how to do it?
Yeah. Again, there are people that spend their careers doing these kind of analyses, particularly in the fire prevention area.
Mm-hmm. But but not in Arizona. No, I'm just kidding.
Yeah, that's a different story. And then this gets into what that FMEA approval process would be. So again, this is an engineering type of an approach.
So is this for like even just any kind of battery, a 22 kilowatt hour battery on a commercial building?
No. At the beginning of the section, it says that if you're not going to follow the rules in here, then you got to do this. So you have basic rules, and if you follow the basic rules, you don't have to do all this.
Okay, so this is if you're not following the basic rules.
It talks about the FMEA.
Provided with permit application. Layout, hourly details on hourly fire resistance rating.
Assemblies, quantities of storage batteries, specs, energy management systems, location of signage, details of fire extinguishing, rack storage, arrangement. Okay, so all that would be required on a general document. Hazard mitigation. Other approved hazard mitigation analysis shall be provided in accordance with under any of the following conditions. Battery technologies not specifically identified. Where more than one stationary battery is provided in a room where there's a potential for adverse interaction, which would be that 3-foot distance we talked about. Or number 3, a basis for allowing quantities.
That's greater than the quantities that we were looking at. There was like 20 kilowatt hours.
No, it's greater than the maximums for hazard locations, which we'll get to at the very end.
Okay. So
500 kilowatt hours for lithium-ion and stuff like that. Okay, so we don't have to get there.
So then we don't need to even do this.
This is not required on every system. Stationary batteries shall comply with seismic design requirements of Chapter 16 and shall not exceed the floor loading limitation of the building. So what it's saying is that there's going to be some bracing requirements and stuff like that that may be required as far as seismic. Vehicle impact protection, that's pretty similar. So where stationary batteries could impact from vehicles like forklifts, vehicle impact protection shall be provided in accordance with Section 312. So Section 312 gets into bollards and wheel stops and all those kinds of things. Combustible storage, this is basically saying you can't store combustibles within 3 feet of battery cabinet. Testing, maintenance, and repair. So the fire code is a maintenance code. So this is talking about if you're going to replace stuff and all, then you have to get approval from the fire code official.
Because like with the NEC, that's not a maintenance code. They don't do maintenance. But the IFC does maintenance, but also does installation, the whole thing.
Right.
Same like NEC kind of stuff.
So they want to be involved. They're saying a fire code official has to be involved. If you're changing electrolyte.
Like you're just like getting out your turkey baster and that's...
No. Well, storage batteries shall be tested and maintained according with instructions. Any storage battery components used to replace existing units shall be compatible. And then introducing other types of batteries into the storage battery system or other types of electrolytes shall be treated as a new installation and require approval. Primarily, the only thing different there would be changing electrolytes or something strange like that. And that would be, call it a new system at that point. The location and construction section. Okay, it says it can't be higher than 75 feet or lower than 30 feet below grade. So it can't be more than 75 feet above grade, above the level of fire department vehicle access, assuming ladders and stuff like that, or 30 feet below the finished floor, which would be how far in a basement that it could go.
Yeah, I had some student asking me questions about this. So I guess, like, can it go, how far up the building can it go? So it can't go 75 feet above the lowest level of
vehicle access. So let's say you had a parking garage next to a high-rise building. I guess if the apparatus can get on the top level of that and provide rescue 75 feet above that, which would be, they have 100-foot ladders. So they can reach 75 feet with some of these large ladder trucks. And so this is for rescue. And it's saying that if you had a fire as high as 75 feet, they'd still be able to provide some rescue support to that.
Maybe it's also for spraying a hose off the top of that ladder?
Could be. Those are the ideas that people throw out there, and that's where some of these things, and again, they're focused on lithium-ion because lead acid and NiCad is exempted. Separation. It has to be separated from other areas in the building, and battery systems shall be allowed to be in the same room with the equipment they support. So the batteries and the inverters and everything like that can be in the same room. Essentially what they're saying is they want to keep batteries away from everything else. It appears that like if you had a large electrical room in a building, high-rise building, they would require you to do the battery and inverters in a separate room and not in that main electrical room. I mean, the last sentence is a little bit obtuse because like battery systems shall be allowed to be in the same room with the equipment they support. Well,
powering the whole building.
They're powering the whole building, so why not? It seems to me that would be allowed from that sentence. It's just not very clear.
And you put your battery-powered hot tub in there too.
Yeah, a battery storage system. They put in an arbitrary number, 50 kilowatt hours, and that each battery array array shall be spaced not more than 3 feet from another stationary battery array. So what they're saying is that you can do them in 50 kilowatt hour chunks, and those chunks have to be 3 feet away from each other and 3 feet away from walls, unless there's large scale fire testing. We'll get to that.
Would that include batteries in a container?
That would not, in my mind, you're going to be using large-scale fire testing in a container anyway.
So if you didn't have large-scale fire testing...
Yeah, and you got to remember, this is for inside of a building.
Why is it inside of a building?
It says from walls in the storage room or area.
I guess I was thinking a container's not a building.
It's not a building. Some might classify it as a building. If you classify it as a building, you might as well, close up shop. Because you'd have to be 3 feet from the sides of that building, and that's never going to happen. So you're going to use large-scale fire testing in a containerized system. And again, this goes back to that principle that I mentioned before, is that you want to encourage people to do the right things, and putting in a container that sits outside of a building away from where it can cause problems is exactly what you want people to do. So you don't want to prohibit them from doing that.
Okay, makes sense. There's the exceptions.
Yep.
Lead acid, NiCad. Does NiCad gas make hydrogen? I remember hearing something.
I'm sure it can. I mean, it's got electrolysis at some level. Nickel cadmium, you got to remember, is it's an expensive battery. And so lead acid is 100 times, maybe 1,000 times more prevalent than nickel cadmium.
Yeah, nobody's really using NiCad anymore.
Not very much. And so lead acid is really the key technology. So pre-engineered systems, prepackaged, shall not exceed 250 kilowatt hours each. And then the question is, those would be separated by 3 feet unless there was large-scale fire testing that would allow them to be put closer together. So this is where we get into larger capacities.
Okay, fire code official, authorized, approved, listed, pre-engineered.
Yeah, goes into details about what would be, an approval path for those things that didn't match up with these basic rules.
Where stationary batteries are installed in a separate equipment room that can be accessed only by authorized personnel, they shall be permitted to be installed in an open rack for ease of maintenance. Stationary storage battery located in an occupied work center, they shall be housed in a non-combustible cabinet or other enclosure to prevent access.
So if you're in an occupied area, then they want you to contain it in a non-combustible cabinet that prevents unauthorized people from touching any of the energized parts or the equipment.
Yeah, and it's like you're usually going to buy something that's already comes that way anyway.
Probably. You could build something around it or put it in a room that's locked that unauthorized persons can't go in.
Cabinets contained in cabinets shall be located within 10 feet of the equipment they support.
In occupied work centers. And I don't know why there's a stipulation on that.
That's kind of weird. Be within 10 feet.
10 feet of the equipment.
Weird. Like you can't just have a long wire.
Yeah.
The further away, the better, maybe.
Yeah. You got to remember this is still the 2018. And so they're still throwing stuff against the wall in 2018. 2021 is a little more involved because the process of 855 brought a lot of people together to develop rules. And so those rules are better than the rules that were in the 2018.
About signage, and so I guess your sign contains this.
Battery systems, electric circuits, and the types of storage battery.
Cabinet signs.
Voltage and current rating of the battery contained and indicate relevant electrical chemical hazards. Okay, fine.
I guess a little different than NEC. We don't have to put the types of chemical
hazards, yeah. Installations in outdoor enclosures or containers that can be occupied for servicing, testing, maintenance, and other functions shall be treated as battery storage rooms. And it's like, why? Well, they're dangerous. And I think that comes back to the fire in Arizona.
Yeah.
It's like, that fire happened after this went into effect. But they're saying, well, that's a battery room there. And it's like, well, okay. I mean, it could be viewed that way, but this says it has to be. Okay, well, I'm going to build a container where all my access is from the outside then. I don't know. It just seems a little bit over the top.
Yeah.
And there are confined space concerns. There's all kinds of concerns with having people enter these things. And so the question is, what's an appropriate measure? To call it a room is problematic because we got all these rules that says it's got to be 3 feet from a wall and stuff like that. And it's like, no, you can't do that.
Yeah. So this is stupid and they'll change it.
Yeah, it's problematic.
They could do the fire testing.
Right. And so the fire testing would allow them, and that's really what it all comes down to, is that people are having to do fire tests for a lot of things.
Oh, containers shall be not required to have that 3-foot space from the container walls.
Right. And that's because that was an obvious stupid.
But what about from each other module?
Yeah, you would have to have that fire testing to prove that.
And it seems like the safest place to have a battery is in a container in a field. Just let it burn.
Yep.
Just don't walk in there.
Right, exactly. When it's having problems, do not walk in it, and that's what the guys in Arizona will tell you. They improperly informed and got in there.
Making sure there was no babies in a burning container.
Yeah. So it has to be 5 feet from lot lines, public ways, buildings, stored combustible materials, hazardous materials, high piled stock or other exposed hazards. That's the basic 5-foot rule. If you're 5 feet from anything in an outdoor location, don't worry about it. So as long as you keep it 5 feet from everything.
And then fire code could give you a smaller distance. Means of egress, separate from not less than 10 feet.
What that's saying is that systems, this is for outdoor, shall be separated from means of egress.
So you want to, like, out that door, your battery, you don't want to have something within 10 feet of it? So like another battery? Like another container?
I think what it's saying is that you want to be able to get out of whatever you're in 10 feet.
Like, so you got a 40-foot container?
I don't really understand how to deal with this. This is an outdoor installation. So it seems like you're already outside. But if you're inside something outside, so you've got a door to the building, and you don't want to put this thing too close to that door coming out of the building.
Oh, I see. So like you're not going to put a container battery within 10 feet of the door of your building.
Right. So if the door to the building, and you had parking spaces right next to the door of the building, you wouldn't be able to put it in that parking space right next to that door. You'd have to go to the next parking space over.
So this does not mean leaving the battery room.
No.
What they call a container.
It means egress from the building. You can't block the egress from the building.
Okay.
With a battery.
Secure outdoor areas shall be secure against unauthorized entry. So you're going to put a fence around it or something.
Or you're going to lock the doors on your container.
Or lock the container doors. Yeah. When a stationed battery includes an outer container, the unit shall only be entered for inspection, maintenance, or repair, and shall not be occupied for other purposes.
So you don't want to put office space in there. Say, hey, our new intern needs a place. I think there's a little bit of room in that battery
keep them
container
warm
back
in there too. Yeah.
We get into Group H construction above a certain level, and we're going to see that in the table. That's where you now are put into hazardous location requirements, and so that brings in a whole bunch of new requirements for that location, including like the lighting systems have to be rated for hazardous location. Your switches, everything has to be hazardous location rated. Exception based on hazard mitigation analysis. That's the FMEA that we talked about at the beginning, and large-scale fire and fault condition testing, they can basically go above that level. So it's basically an out because you've looked at all the angles and looked at all the problems and issues. Without that, you have to be considered Group H. But you could get away from Group H requirements. So, for instance, for lithium-ion would be 600 kilowatt hours. Instead of going to Group H2, you could have a 1 megawatt hour facility inside of a building, but you've done all this FMEA analysis and everything like that, and therefore you don't have to be classified as Group H2. That is totally up to the local jurisdiction, that the analysis is adequate and all. So it's difficult. And like I said, that's kind of a gamble that I would be hesitant to take. I would rather put the stuff outside.
Yeah, and I remember we did some consulting for a company about a year ago. That was some of the things that were the big deals that were coming up. I remember was that they were talking about putting containers indoors. Was
right.
And and you're just like, why would you do that? It's like you're going to have a greater chance of one catching the other. And then you were mentioning how they can just put the containers outside, and if something is going to catch on fire, they could always flood it. I thought that was kind of interesting. So you could just like have a nozzle where you just hook the fire hose up to it, wrecks everything inside of there, but it just drenches it, puts everything out. I know that elemental lithium is very explosive and it reacts with water, but lithium-ion batteries have very little lithium in them. Actually, they're mostly nickel.
Right, and they're not explosive at all when exposed to water. Yeah. So whereas lithium is, elemental metal lithium is, you don't do that. That's the thing you play with in the lab.
I remember doing that. It wasn't really a lab, but I used to know a crazy welder.
Yeah, it's not going to do that. And so certainly one of the fire suppression methods that I think has a lot of merit is that if the container is going to be a total loss anyway, and the safest thing to do would probably be to fill it with water and just let it, absorb the energy over time and monitor it. All those things are problematic because the energy storage stores so much energy that it takes a long time for that energy to dissipate. And so the challenge that it brings is that the fire department is supposed to stay on on site until the hazard has been removed, which in a typical fire is no big deal, right? You put the fire out, you basically go through and they do overhaul, which actually pulls walls out, pulls sheetrock down to make sure there's no fire lingering behind the walls and things like that. And once they've confirmed all that, and they even use like infrared thermography and cameras to look for fire and stuff like that, they can pretty much put the fire out. But this, it's like, well, come back in a week and, maybe we'll be good.
Think you just flood out a lithium-ion battery and it won't just turn off?
It will eventually dissipate its energy, and to the extent that it doesn't dissipate its energy, it'll probably ruin it.
I think that's what those guys were saying, was they were worried about, like, when's the point where you just say, this is a loss, flood it, versus, we can save some of those battery modules in there.
Right.
Then also they were talking about having a building. I can't remember if it was like they had containers in the building or just a bunch of racks maybe in a building. And they were talking about, then you would have to flood this, millions of dollars worth in a big building.
Then the question is, do you have removable sections that you could physically just literally drag outside? Because if you
maybe
can't...
not while it's on fire.
Maybe not while it's on fire, but maybe you get it to the point where it is movable, even though it hasn't dissipated its energy yet. So you could isolate the module and get it out. And so there's all kinds of ideas on might be the way to do it. All of those have challenge. And I think they're increased by when you put them inside a building.
And I remember this other thing that we were talking about. They had something that would, suck the oxygen out of the air, or was it an aerosol or something like that?
Yes, that's one way to fire mitigation, is get rid of the oxygen.
And then you were even recommending against that because you get rid of the oxygen and then more gas builds up.
Yeah, well, some of these explosive conditions may not need a lot of oxygen. Again, all those things have to be looked at in FMEA. That's what an FMEA is doing, is looking at all those details and determining, is this really a viable method of dealing with this particular hazard? And quite frankly, that's the big boy stuff, and there are companies that are specializing in that, but there's still a lot unknown about that. And that's why I say, in the meantime, you stick it in a container, you put it outside, you heat the container to keep it warm in the wintertime. So you might insulate it with some non-flammable materials and stuff like that to keep it warm, and then have a heater in it so that when you're not in a heavy charge or discharge cycle, you may actually have to augment the heat in the system. In charge and discharge, you probably wouldn't need to augment anything because it's giving off a lot of heat.
Maybe you could use it more when it's colder.
Yeah, more of a problem in the summertime to provide air conditioning or cooling inside the thing. But at the end of the day, I'm not putting at risk anything in my building. Now, I could build a building that had no other purpose than doing this. And that would be part of the FMEA. And that would be part of who's allowed in that facility. That would be qualified persons. And they would only be allowed in there for certain maintenance activities. And you wouldn't have office space in it and all that kind of stuff. The only times any rescue of people would ever have to occur is when something bad happened, when a maintenance person who was a qualified person was in there. And that's a very different story. Those are the things that you have to think about, and massive energy storage systems are going in around the country, and most of those are outdoor containers.
And so we're typically looking at lithium types, but we have other types there too. What's H2?
It's just the group H2 occupancy. So it's a hazardous location. There's a variety of hazard location, H1, H2, H3, H4. This is a classification in the building code that you'd have to apply.
What would a H2 example be like?
I really couldn't tell you right now.
H2 is hydrogen, right?
Yeah, exactly. But that's not what it stands for. I think it's safe to say, in most cases, I think it'd be foolish to try to obtain that construction category. Because it would be very expensive. So you'd have to have a really important reason, like it was a NORAD bunker facility and they had to put it inside and they had to have it near other equipment and stuff like that. So then you basically had to go to this extremes that cost you 10 times as much. If you're doing this for cost purposes, which that clearly would not be for, then you're not going to be going to H2 at all.
It says like lithium, 600 kilowatt hours, H2.
It's just saying that if you're over 600, so that's the maximum.
Over 600.
That's right. That's the maximum. If your battery capacity is 601 kilowatt hours and you're wanting to stick it inside the building, you're not doing the FMEA and okay, you got to make that occupancy group H too. Then you've got to have special lights, special outlets, special switches for the electrical. You've got other types of things.
A gas station or something.
Yep. You've got all kinds of special rules that you just got to go to those rules and see what applies to your building.
Now we're talking about 1973.
Storage batteries shall be listed in accordance with 1973, which, for instance, a residential example would be the LG Chem.
Yeah. And so that's pretty much just like, that's a DC battery. And the way I look at it too is 9540, that's like with an inverter, right?
Not always with an inverter, but the ones that we're going to be seeing most often would probably include an inverter.
Can you even think of one off the top of your head
Yeah.
where you'd have 9540 without an inverter?
You could have an energy storage system with a DC converter.
Nobody's really selling them, like for your DC microgrid, I guess, or something.
I think what we will see in the future is 9540. The LG Chem system could be a 9540 system all to itself because it's got a converter in it.
Mm-hmm, sure.
If it can do its own battery management and its own battery control,
Wouldn't have to have all the inverter companies go through some complicated listing with
right.
it to use it?
If you turn the switch on and it does everything, the LG Chem battery has to communicate with the mothership to work. It won't even turn on.
Yep.
So that's part of the system. Whereas if you built a system that didn't require that connection to the mothership and it just says, hey, you want electrons? We'll give you electrons. We'll take electrons when we ask for electrons, and okay. Which a dumb battery does, a lead acid battery does, okay? But then it has all these protections that prevents that lithium-ion battery from ever seeing anything bad.
But for the most part, like today, if you were going to go buy anything that's 9540, that's AC.
Everything on the market that I'm aware of is AC. They have this massive exception that says if it's lead acid, you get out of jail free card. So it's basically what they're saying there is that lithium-ion batteries and flow batteries have to be UL 1973.
Prepackaged and pre-engineered.
Shall be installed according to the manufacturer's instructions. No, throw those things away. Those manufacturers don't know anything about batteries.
Instructions.
Anyway, whatever, yeah.
So we can't have the people that don't read instructions.
That's right.
It takes out a lot of the population.
Okay, energy management system. This is really referring to a battery management system. When we talk about energy management system in the National Electrical Code, we're talking about stuff that controls loads and stuff like that. Yeah. That's not at all what they're talking about here. They're talking about a battery management system.
BMS.
A BMS. Monitoring and balancing cells.
Are they going to change this in the next version, do you think?
Yes. Yeah, and it has alarms and all that kind of stuff. And that's absolutely required for lithium-ion. Cannot run a lithium-ion without that.
I've heard some people like saying that, oh yeah, you can do it with lithium iron phosphate because it's safer, but they're just full of it.
Yeah, it's BS. It's not BMS, it's BS. They got rid of the M.
It's not bowel movement shit.
Notice that it says for battery technologies other than lead acid, nickel, cadmium. So lead acid, nickel, cadmium get away free with energy management. Now that in and of itself is problematic because do you need to manage a lead acid battery or a nickel cadmium battery? And the answer is of course you do. Okay, those controls are very simple and they may not be cell level, but they absolutely are required. And so that's where we're getting in the newer code sections is actually talking about 9540 in the context of a charge controller, if you will, in the old school way of things with PV, is we have a charge controller that does the management of the battery. And absolutely, just because it's simple management doesn't mean it's not management. To give people the impression that a lead acid battery doesn't need to be managed is absurd. Okay, it's much more critical for a lithium-ion battery to be managed down to the cell level, whereas a lead-acid battery can be adequately managed from the overall battery voltage rather than at the cell level.
I've always thought that there's probably just crossover, or maybe it's the same thing, saying like, what's the difference between a charge controller and a battery management system?
Yeah, a charge controller is the conventional way that we described battery management for a lead-acid battery.
Like a BMS that's not as close to the battery, it's like could be external. So could you have like your lithium-ion battery management system 10 feet away from the lithium-ion battery, I guess?
As long as it has all the data. Yeah. See, it's got to have temperature sensors, it's got to have all kinds of information in order to perform that function adequately. The brain can be on the other side of the planet for all that matters if it's uploading information to the web.
So is that like your system that right here behind you? is that battery management system the charge controller?
So this has a charge controller in it. It basically controls how much voltage it allows it to present to the lithium-ion battery.
Does that lithium-ion battery have its own separate BMS?
Absolutely. Internally, it does. Okay. So it's just asking for a voltage source that's between these two voltages. You give me voltage between these two voltage, I can take care of the rest. I do all the stuff down to the cell level. And so the only thing that guy has to do is make sure that its voltage stays within a certain range.
That's an Outback, and what kind of battery is it?
This is a Simplify battery.
Simplify. Battery chargers.
And that would be an example of something that would be for lead acid batteries. Compatible with the battery chemistry. Okay, it's going to be a lead acid battery charger. Great.
We always call it an inverter, but when we have a multi-mode inverter, it's a charger too. It's an inverter charger, so that maybe we need a different name for it because it goes AC, DC in both ways.
And it says that it has to be listed and labeled in accordance with UL 1564. That was just UL's way of getting their name into the code one more time. And so if you buy a listed lead acid battery charger, it's going to be listed to 1564.
So does that mean a multi-mode inverter, isn't that like a Sunny Island, is a lead acid battery charger?
It is, but it's not listed to 1564. It's listed to 1741.
But it says here it should be 1564. So is it wrong?
Pretty much.
It's wrong. Inverter 1741, we always know that.
Yeah, so basically what we're going to do is if somebody gets hung up on that last slide, which is really common, isn't a battery charger. If it was just a battery charger, 1564 is your standard. Inverter that does charging, that's different. That's not a battery charger. It's an inverter that has multiple functions to it, one of which is battery charging, and that's covered in the 1741 standard.
I know the NEC definition for inverter, it's going to be DC to AC.
Correct.
Not the other way around.
But this is the fire code. Okay. And these firemen don't know anything about DC and AC.
Safety caps. Flame arresting safety caps.
Is this like a baseball cap or what?
I think so. They got to be bright orange.
Bright orange baseball caps. No. Flame arresters are common on flooded lead acid batteries that give off hydrogen gas. And so the flame arrestor cap is a safety cap that if there were a fire, then that fire would be arrested through the cap and wouldn't make its way into the battery.
Okay, so it's not going to go into the battery. So this has nothing to do with not a flamethrower.
I don't know. It'd be interesting to see. Probably a YouTube video of a battery on fire that you could take a look at. Thermal runaway. A listed device or other approved method to prevent thermal runaway. Anyway, how do you prevent thermal runaway in a lithium-ion battery? It has a BMS and it's listed to UL 9540. How do you prevent thermal runaway in a lead-acid battery? You put a charge controller on it.
Thermal runaway, I guess let's maybe define that.
Yeah, thermal runaway, I've never been a big fan of the term. It actually started with lead-acid batteries as a term, and it basically says that in the context of batteries, the battery has internal energy that's stored in it. And that internal energy is propagating the fire. Typically, it could be just temperature, but what we're talking about is that it is a self-propagating activity. It's not coming from the outside, it's coming from the inside. So that's the way to think about thermal runaway, is that the energy that's inside that component, that system or whatever, is providing the energy to force the thermal event. Now, a thermal event will become an open flame if it's exposed to oxygen and has flammable materials, but it may never actually become an open flame. It could just become a molten mass of yuck. Okay, that is in thermal runaway. That's just like lava. But that energy of the lava is coming from the battery itself and the chemistry of the battery.
I always thought of it being like you get a bunch of batteries next to each other and one burns up and then it catches the next one.
It's self-propagating.
And it might not self-propagate fast.
Right. It doesn't have to be fast. In fact, it can be very slow, painfully slow. But as long as it's able to continue to propagate, you got a problem on your hands, because unless you're going to stick your hands in there and stop it, which you're not, it's going to keep on going forever and ever. Basically propagates throughout whatever it can propagate. And so that's why these battery systems that are in lithium ion, for instance, they have separators. If there were to be a thermal runaway event, it would only propagate up to this point, and then there's something that separates it and prevents it, and they do fire testing to show. And Tesla's probably done more of this than any other company out there.
They got cells, modules, and packs.
Exactly. So they break things up that way so that they can provide that break in the thermal runaway process so that it won't continue to take out the whole car.
Yeah, and I remember hearing something about when they were first developing it, like when you get an accident, like it not only makes the airbags go off, but it just disconnects the battery all over the place.
Right. So you have interconnections because a voltage applied to the circuit in a thermal runaway could make it worse.
And maybe that would happen if you ran your car and hit the thing in the wall.
Right. One conductor could hit the metal frame in one place, and then another conductor hit the metal frame in another place and create a short circuit.
Thanks for listening to Sean White's Solar and Energy Storage Podcast, where you can talk about exciting things like battery fires, or at least how to prevent battery fires, which is even more exciting. To learn more about everything solar and storage, go to Solar, SEAN, that's SolarSean.com.